programs here in the Walter Scott Jr. College of Engineering. So I'm your point person. If you need anything, I'll be sure to drop my email in the chat today as well. So if you want to connect after today, let me know if you have questions. If you want to set up a one-on-one meeting, I'm here to help. So definitely know you've got people to serve as resources as you navigate the college search process. Great, it looks like lots of people are logging in now. Perfect. And then I did just want to let you all know we are going to record that session. So hopefully that's okay with you all. These sessions from Engineering Exploration Week will all go onto our engineering YouTube channel, so you can watch them at a later date as well. Perfect. And I'm still hearing lots of doorbells, so we'll probably just hold a minute until we start officially. Perfect. And to get started, maybe in the chat, if everyone wants to maybe drop something that they're interested in, if they're interested in water quality, water resources, structural engineering, maybe think about something you'd like to learn about today as well. And let us know how we can help answer any of your questions. So we want to make the session as interactive as possible. All right. And I think now we've got most people, it looks like doorbells are slowing down. So I think we've got most people here logged in. So I'm going to go ahead and pass it over to Todd and Shannon. So again, thank you for joining us for Engineering Exploration Week 2020.
Good morning. My name is Todd Atadero. I'm not sure if Shannon is available. She wants to say hello as well. If not.
Yeah, thanks, Todd. I am Shannon Miller. I am the undergraduate advisor for Civil and Environmental Engineering, and I will actually be with you through most of the day today. So you can also reach out to me and ask any questions that you have or put them in the chat. And like Jackie said, we want it to be really interactive and get you some answers to any questions you have, and also get you excited about our major. So Todd's going to show some information about the labs and stuff that he does around our department. So thanks, Todd.
Thank you, Shannon. So today we're going to start you out with a lab tour around our different undergraduate labs here. First quick, hi, my name is Todd Atadero. I'm the Undergraduate Lab Manager here. I am an electrical engineer, so if you have any very technical questions, you probably want to save them for later, but I can answer a lot of the basic questions about what's going on in the labs. I was previously an engineering manager for another company, so I had a lot of design and documentation experience. So for those of you doing your lab reports, know that yes, you do have to spend a lot of time and effort in those. But most importantly, I spent a lot of time doing lab safety. And so I have a background in making sure experiments are safe, machines are safe, focusing on keeping people and students away from machines, and wearing your PPE while you're in the lab. So I spend a lot of time focusing on making sure the students are safe while they're in the lab so that we can all have a good time and enjoy what we're doing in them. But you're not really here to hear about me, so we'll move on to some of our labs. Kind of the reason for having labs, engineering just isn't textbooks. You're going to spend a lot of time in class deriving formulas, working out a lot of problems on paper and notebooks. And we have a strong belief here that you can't just learn engineering out of a textbook. We want you to get a hands-on experience of what's going on, be able to see kind of what you're learning in the classroom firsthand, maybe even play around with some experiments yourself. Also, in the classroom, you'll be working with very idealized scenarios. Say you're working with a wood beam, it's going to be very uniform throughout when you're doing your calculations. Whereas in the real world, you'll have defects, issues with that. If you're designing steel, it won't be quite the same all the way through. And so we want you to be able to see kind of that difference between real world versus the idealized classroom environment. And that will come into play later on in your career as you start talking about things like factors of safety and how they actually do design. And finally, it's just a lot of fun. We spend a lot of time breaking stuff here, and it's fun to see things crack, get pulled apart, maybe explode. It's just fun to kind of go in and watch what's happening. So when you come into Colorado State here in civil environmental engineering, one of your first labs will actually be in surveying. To solve a lot of the problems in civil and environmental engineering, you kind of have to know the lay of the land. You can't build a building without first knowing what the foundation is going to look like. You can't solve pollution issues and water runoff if you don't know how hillsides are laid out and know where that water runoff is coming from. And so we want to make sure you have a good background in understanding kind of how land is laid out. In these survey labs, we use a couple different pieces of equipment. Kind of seen here in the picture, we have theodolites, you have auto levels, and you'll have your handy dandy notebook. Some other equipment that we like to try to at least get you some knowledge on and experience with will be mechanical total stations, robotic total stations, and GPS devices. You'll see more of those used out in the real world, but we like to focus on some of the more basic ideas so that you can learn how survey is done kind of basically and make sure you get all the math in. So here's our theodolite. It's primarily used in land survey. You use this to take horizontal and vertical angle measurements between points. And then you go out and take some distance measurements, and using those, you can use your trig and geometry and do some triangle calculations to where you can actually start laying out points on your map and figure out exactly where they are. This is our auto levels. They're more accurate than theodolites for checking the levelness of, say, a foundation. Internally, you have to kind of level out the tripod, and then it has a hanging prism from a string that kind of levels it out much more accurately. This is very important for when you're doing, say, construction work and you're laying out a foundation of a building. You don't want that foundation to have some kind of a tilt to it. You want to be perfectly level, perfectly horizontal. And so these are the tools that they will use to kind of determine how level that foundation is and make sure it stays level. And then of course you have your notebooks here. You'll see some examples of work that's done in the past. The students get to check this equipment out, go out for lab, and they actually go out and take measurements and will map out different areas of campus. This will be just like you do back in the field in earlier days. One nice note to know about this, and you may be saying, well, what does survey have to do with civil engineering? We have had students in the past get internships with CDOT, the Colorado Department of Transportation, actually going out and doing survey work for them during the summer. So they'll go out and check roads, they'll go out and check bridges. And so it's kind of an important class. We'd like you guys to learn about this. After surveying, as we move into later on in your coursework, we'll come to our class on materials for civil engineering. And one of the first labs you'll get involved in there is the concrete lab. And so this is a picture of our concrete lab here. On the left-hand side with the gray boxes are curing rooms. The green machine there towards the left-hand side is our shaker machine that lets us kind of separate aggregates out. Our blue machines here are our concrete cylinder testers. This is where we actually break the concrete. And then off to the right will be where our actual mixers are. As part of this class, as I was mentioning before, we like people to kind of get a lot of hands-on work. So here you'll actually design your own concrete mix, where you will go in and measure out your cement, measure out your aggregate, measure out your water, and try to design your own mix, and then we will test it and see how strong it is. Most cores usually come out to 7,000 to 9,000 pounds per square inch. That's how much pressure they can handle. Most students' first mixes usually come out to 200 to 1,000 pounds per square inch. That's expected. We don't expect you to know a whole lot about it. And so because of that, we actually invite in the Colorado Ready Mixed Concrete Association to then come in and show you how to mix up concrete themselves. And then they will take you through some tests so that you can get an ACI certification for concrete field testing. I think it's a technician grade 1, where once you've gone through kind of the class with us here, you can go take a test, a written and then practical test. And if you pass, you actually get this certification. So we're going to take a quick look at a video here of them kind of going through mixing the concrete and how they make it. So here they are kind of weighing out the aggregate that goes in the concrete. And then they have a couple different chemicals they like to put in to slow how quickly the concrete will cure, or say air entrainment, which helps the concrete as it freezes and thaws, especially here in Colorado. We want to make sure it doesn't break. They'll get a chance to mix up the different aggregates and cement in our mixer. You will see here, there it is, kind of mixing inside the mixer. We pour it out, and this will be kind of a good standard mix. They will kind of explain to you all the different components that go into it. So as you can see there, it's beautiful, nice and gray. So then they'll start showing the test for the technician certification. This test is a slump test. They will go through, so as you see, there's a metal container there, kind of a conical shape. You'll see them here kind of making sure the concrete is compacted in correctly and settled in correctly. These are all steps you would have to take if you're showing an examiner how to do this. This test is to determine how workable the concrete is. So as they pull up on this cylinder, you will see the concrete slump out, and then they would take measurements to see how far it collapsed down, and that'll tell them how workable the concrete is at this point. This here is a test to check the amount of air in the concrete. Again, air is important here in Colorado and anywhere that freezes, because we want to make sure the concrete has room to expand and contract so it doesn't fail due to freeze thaw. They put the lid on top of it there. They'll fill it up with water. They'll pump it up on top and shoot some air into it, and then they'll be able to take their measurements from it. As part of that, we will also fill up some core samples. You see the orange cylinder holder here on the right. We'll fill that up with concrete, let it cure for 7 days, and then we will actually go out and test it on our machines here. This is our curing room. Try to control the environment in it. Here's our concrete cylinder tester. There's our failure right there. Not the most exciting thing, but as you see, it kind of shoots out and breaks. Some failures are going to be a little bit more exciting than others, but that's kind of the fun of doing the labs. So that's our concrete lab. Across the hall is our materials lab. So again, part of that same class, we go over not just concrete, but we'll go over steel, we'll go over wood. This materials lab, we kind of lovingly call our smash lab, because we like to go in and break a lot of stuff and let you see it break. There's two kinds of testing in civil engineering that are very important. One is non-destructive testing, and the other is destructive testing. Non-destructive testing is important because, say you're going out to a bridge, you want to see how it's been degrading over time. You can't just go out and drill a concrete core out of that bridge because you're going to weaken it. And so there's ways that they can go out and actually test that concrete to see how it's doing. They can test a rebar to see how it's doing inside. And that'll give you a rough estimation on how the concrete rebar, the material, is doing. However, to actually get a good measurement of how these materials respond, we need to actually go in and break it. So you can see here, here's our wood beam buster here. We'll take a look at that. This is our torque machine where we twist metal bars. This is a universal testing machine called an Instron. This is our Rockwell hardness testing system. This is, again, a machine that does our non-destructive testing, where it will apply a known force to, say, a steel sample. It'll make an indentation in there, and then we can measure that indentation and get a rough guess of what the tensile strength of that steel is. However, that's just a guess. We actually want to know what that tensile strength is. So we'll put it in our machine and we'll actually pull that steel apart. You can see it necking there out, and it'll continue to do that till it fails here. Here is our torque machine. Again, we kind of anchor down one side of a metal bar, twist the other side. We draw a black line across the top, and you can watch it make a candy cane shape, and we will twist that bar until it breaks. And you can measure the force that is required to break it. Here is our beam buster. We'll test a number of different wood samples. I believe this is a 2x8 beam, we'll also do what are called LVL and I wood beams. This has high hydraulic pressure, and we can measure the force required to actually break this beam. And we don't just like to break it a little bit, we like to break it a lot. This is our Sharpie testing machine. Oops, of course that did that. Oh, you're not gonna let me fast forward on that now. Well, that Sharpie tester will have other ways of testing metal samples. It has a hammer on it, it will come down and break stuff. And well, we'll move on to our fluids lab. That was the last test I think we're going to take a look at. Another class you'll have is your fluids lab. Here you can kind of see the top-down view of it. We share this lab space with the mechanical engineering department because they do kind of a fluids and thermodynamics lab as well. Let's take a look. You'll do a number of different tests in here. You'll test ideas that you learn about in class, such as viscosity, specific gravity, pipe flow, and how the pressure in a pipe will change between when it's kind of a smooth pipe versus a very dirty and rough pipe. You can look at things such as cavitation. Let's see here. Let's take a look at what experiments you can do here in this lab. So I believe the first one is fluid rotation. We have a machine that'll rotate at a constant rate, and you can measure how high the fluid kind of works its way up the side of the walls due to the centrifugal force. We have our momentum system here. Here we have a known head pressure, how strong the water is being forced through a pipe here. You have a known opening here, and based on that pressure, it blows up against this plate, and you can measure how much force is that water is exerting on that plate. Here's our closed flume. In this, we fill it all the way up with water. You have a port here that you see that hole kind of in the middle. What we do with this lab is you'll have a cylinder with different points that we can measure pressure across that cylinder. And we'll kind of take measurements and see how the flow across it changes across that cylinder. We then pair this with a lab on CFD, computational fluid dynamics, where you'll sit in a classroom and actually use the computer and see what the computer says, what those flows will be, what those pressures will be, and then you compare it to real life actual measurements that we take. Next will be our open channel flume. So here you see open channel, so it's not closed. This is a hydraulic step where you have, say, like a drop or a spillway, water running quickly on one section, suddenly hitting a higher, slower moving section of water, causing kind of a quick jump. So you can see our poor rubber ducky there gets stuck. We have other tests that we do here. This is a V-notch weir that lets us measure the flow of water through this weir. And then we will have, I believe it's a narrow crested jump or weir. To see it makes a very strong S-shaped curve there. And then we will have a broad crested weir that we'll take a look at next. We call this lab our wet lab, as you'll see here in a second. Sometimes our TAs have a little too much fun with the system and we'll start spraying water everywhere off the jump. But this is our broad crested jump, and that makes a little bit less of a pronounced S shape as it flows over the step. And then they just like to have fun. They'll put in a bunch of different stuff inside the flume and see if they can make a number of different steps. And they let the students kind of play around with it and see what they can do as well. That's our fluids lab. Next, we'll move on to our Geotech Lab. If as a kid growing up, the thing you like to do most is play in the sandbox, well, this will be the lab for you. One of the first labs we actually do here is building sandcastles. Now you may say that seems like kind of just having fun playing around, but it's very important when you start dealing with geotech and soils, because for this lab you'll actually have to take sand and determine kind of scientifically how much water you want to add to that sand. Too little sand, it's going to collapse, and dry sand makes a pile, it doesn't do much. Too much water, it becomes almost like quicksand. And so you'll be competing against other teams and groups in this lab to see who can build the tallest sandcastle. In geotech, in the class, you'll learn about things such as earthen dams, building foundations on top of soils. How will the soils react when they have pressure applied to them? How does water flow through soils? You take like things like the Leaning Tower of Pisa. Everybody always sees that, kind of lean over on its side, have discussions of why stuff like that will happen and how to deal with it. So kind of a video here. This is one of our faculty members, Dr. Chris Bereither. Going to kind of just show quickly scooping some soil into some of our sieves to separate it out so you can get a different breakout of the different size samples that you'll have and measuring them out. But then we'll take a look at a lab testing the flow of water through soils. So this device here is called a permeameter. As we kind of said before, we like to have our students get hands-on and kind of do their own designs. So for this lab, their goal is to measure how permeable a soil is to water. And other than giving them the basic tools, they have to go out and design their own experiment for this. So we'll kind of take a look here at how they design their experiments. So first they got to fill up their device with the soil in question. And we'll see here as they move on from this. Here is one design. The idea is to try to have a constant head. It makes the measurements much more simple. These students here are actually doing a variable head where they can measure how quickly the head of the water is changing. That requires you to then use calculus instead of some basic equation calculations to see what the how permeable that soil is to water. Other students, as you see here, use a device that allows them to fill it up from water from the sink. It then overflows and keeps a constant head on that device, so then they can have a constant head pressure across their soil. Here's our TA now doing some compaction tests, making some soil samples so that we can again go out and break things. As I said, one of the things we love to do here is break things. We then put it in some of our testing machines here. Here we're going to, it's called a unconfined sample test. You build up your soil test. It has a known quantity of water in it. We then crush it to see how much force that soil can actually handle. Now, we didn't break it very far, and that's no fun, so we like to usually come in and smash things completely. You'll do other tests in this lab, such as confined soil testing, shear testing, and it's just a lot of hands-on and fun work. Like I said, if you like playing with soils, if you like getting your hands messy, this would be a great lab for you. As you get through your classes in civil and environmental engineering, you will then have a chance to kind of separate whether you're doing civil, water, or environmental. As you switch over to environmental, we have in our environmental lab classroom seen here. It's a little messy right now because we have one of our faculty members doing some work out of here while there is not a lab in it this semester. In this classroom, usually we're doing a lot of water analysis. And so one of the labs that we'll be taking a look at is our Civil 441 class, Water Quality Analysis and Treatment. In this class, you'll spend time learning how to measure contaminants in wastewater and industrial water. If you've ever had a fish tank, you will kind of know what some of this stuff is, but they'll measure total dissolved solids, total dissolved organic solids, the pH of the water, the nitrates of the water, how many phosphates are in the water, what the dissolved oxygen in the water is. All these components are important to the environmental health of the water, drinking water. stuff like that. So you'll learn how to take measurements of it, what it actually means, how does it apply to environmental testing, how to solve issues that may come about from the different values of this. But again, we don't want you just to be doing basic tests. We want to give you a chance to do your own designs in lab. And so part of this lab will have you do your own project design. You'll be given a situation. Different situations used in the past are, say, natural disasters leading to water contamination, or you're out in the field and you suddenly need to use a point of use water treatment to get water for yourself. And they use a couple other different situations. But based on the situation, based on the materials around you, they will ask you to design your own water treatment plant. So let's take a look at some of what our students have done in the past. This is a quick slide. These students had their situation being they're out in the field doing water quality measurements on a lake, and a bear gets into your camp and destroys your campsite, including your water filtration device. Now you have to take water from the lake and actually filter it so that you can drink from it. We will contaminate your water, as you see here on the left-hand side, with all kinds of different things. So we'll put in, like here they have pine needles, they'll raise the pH, they'll put a lot of nitrates and phosphates in the water to dirty it up as much as possible. And then on the right here, you can see one of the student labs, that's how much they cleaned it up. You will be competing with other students in your lab to see how much you can recover from your water, how much you've cleaned your water up, how fast your cleaning system was able to do it. As you can see here, here's kind of one of the designs that they had, a gallon container that they then kind of put in some charcoal layers, some gravel layers, some cotton balls, and then they try to collect the water at the end. Here's what their design looked like. So again, it's not pretty, but that's kind of the idea, is you're designing the best you can with the materials you in theory had available to you. After they've done the design and run their water through it, they'll go through and kind of test out all the different readings that they had. They'll have their initial readings from the first set of water, and then the readings after they clean their water out, and they can see how close they were to actually getting it to be drinkable. Don't worry, we don't actually require you to drink your water sample at the end. Most teams don't get close to actual desired drinking water levels, but that's okay. We expect you to kind of fail here. It's just kind of a fun project. Different teams will do different things. Here you have a team doing a distillation process. So saying, hey, we have a campfire, we have some pots and pans, we're gonna boil it up and see what we can do. Other teams will try to get the best of both worlds and do a basic filter system here and then boil it off and see what they can recover. Again, one of the measurements they use besides all of the pH, nitrates, phosphates is how much water you actually recover from your tests. So again, it's kind of a fun hands-on approach, and it lets you take what you are learning in your lab in your classroom and actually apply it to what may be a real world issue. So after all of our labs that you do and all the labs that you go through here at CSU, and I am sure we will talk about this more as you get into other presentations, your last year here at Civil Environmental Engineering, you'll have a senior design project. This project is kind of your chance to demonstrate your ability to solve real world problems using what you've learned so far here at CSU. You will have access to all the lab equipment that we have shown you and then some. So there will be other equipment that faculty will have that you'll be allowed to use. Some things that you will see here in a few minutes. There's a 3D printing lab here on campus that you can use. There have been some groups that have used some VR systems we have to sit down and actually take a look at what is going on in their projects. So let's take a quick look at what some of these senior design projects look like. Here, one team had to come up with a potential reservoir in northern Colorado, because in Colorado, we are always worried about water. And so they went out and hunted down different areas where they could potentially build a reservoir and then they had to design an earthen dam to actually hold the water back. So you'll see them doing maps, potential survey work, computer work and handwork, actually doing soil tests, combining a lot of what they did in geotech and potentially fluids into their senior design project. Here, they're trying to mitigate climate change impacts at Langley Air Force Base. It's surrounded by a lot of water, so you're dealing with rising sea levels. And so again, doing kind of a fluids and a geotech work, they're designing different tidal gates, breakwaters, you have your levees and some dams. And you can see here on the table, they were doing some 3D printing work to kind of show their designs that they wanted to use. And a lot of these projects, you won't just talk about the design, but you also talk about the cost that it will take to implement your actual plans. So you can kind of see some cost breakdowns around here as well. And this project, again, kind of an environmental engineering project dealing with Cherry Creek down in the Denver area, doing a nutrient removal unit. You get a lot of runoff of phosphates and nitrates into our rivers around here. And so how do you actually pull those pollutants out of the water? Nitrates and phosphates are in essence fertilizer. And so you'll get a lot of algae that grows from that. And when algae grows in water, it takes all the oxygen out of the water. And when all the oxygen is taken out of the water, your aquatic wildlife has issues. So this team kind of went down and took water measurements of Cherry Creek, and then they came up with a couple different designs for, they have here a floating treatment wetland that kind of grows and takes the nutrients out of the water. They have algae farms that you kind of run the water over, and you can harvest the algae out. That helps clean up the water. So it's a really interesting environmental engineering impact project. This team here, now as we move into more structures and fluids, they had to deal with a bridge that was suffering from different high water events on a river here in Colorado. So they had to go out and kind of take measurements, see what the how the bridge was taking damage, take water flow measurements, and then sit down and actually design improvements to this bridge to make it be able to better withstand our high water and flooding events here in Colorado. And so you can see kind of off the side there, they have some cost estimations, some bridge design ideas. Again, there's another 3D printed bridge there on the bottom. And these worked with, say, the Colorado Department of Transportation, kind of help out. You'll see in a lot of these projects, they're working with either companies or the state to try to actually, again, solve real world problems. This one here, going back to our survey courses that you were taking at the beginning of the year, we are looking at building a new structure here on campus. And so this group was tasked with actually going out and taking survey measurements, actually laying out where this building would be constructed based on Fort Collins City land use laws and requirements. So parking lot layouts, how must things be graded to make sure we have the correct water runoff, identifying how to get the structure perfectly level. So again, they take out the survey equipment, we give them the very advanced stuff. They have a lot of work on computers, so here's their computer layout. Again, they can go into VR and actually take a close look to what they're doing with their site layout to see what works best. And the last senior design project that I'm going to take a look at today is a CSU Big Beam. This is a competition amongst the schools in the area where they have to actually design a beam and see how much force this beam can carry. And so they'll be working, doing concrete mix designs, doing beam designs, and then they get to go into the lab and break their concrete cylinders. They'll take what they've learned about rebar and they'll actually build up a beam. They then take this beam down to Denver where they have a large machine that can apply a large amount of force to it, and they actually break their beams, and then they compete against all the different schools here in the area. So again, another kind of fun structural task that students can do and apply. So that's kind of what we have for our lab tour here. Are there any questions?
Hi, Todd. I just wanted to note that there's a question in the chat. So Adam's asking, so they're interested in sustainability and automation. So can you tell us a little bit more about the opportunity regarding those two disciplines?
Let me see what I can answer about that. As far as sustainability goes, you kind of will have conversations about sustainability throughout your classes as we do recycling, as we talk about wood stuff. They'll kind of have basic discussions about sustainability there. I believe as you move more into your environmental classes, that's where it will become more important. Again, the classes are not my strong point, so I can't give you a very good answer to that. I believe Shannon would probably be the better person to answer that question. As far as automation is concerned, different faculty work with automation around here. I do not believe we currently do too much work with automation. We're looking at implementing a class so you can learn more about sensors, systems, what they mean, how to use them, and kind of how to do some automation work. But again, that'll be more if you want to spend some time working with faculty. I know we have some that do some automation of measurement, doing out and field work, things like that. Again, I know that's probably not going to be a great answer to the question.
Well, and I was just going to mention as well, so there's a ton of ways to incorporate especially sustainability into any degree here at Colorado State University. So that's something we're really well known for, actually. And so I did drop a link to sustainability at CSU. And so one thing that you can think about is you would major in something like civil or environmental engineering, and then you can add in a minor. And so SOGIS is the School for Global Environmental Sustainability, and that's a really great minor that partners well with either civil or environmental engineering. And so that gives you a chance outside of the curriculum in the College of Engineering to explore sustainability and then how that relates to your specific interest areas. Another way to get involved is going to be through research as well. And there's a ton of sustainable research that happens at our Powerhouse campus, which is just a little bit north here of CSU main campus. And there's tons of work that we're doing in regard to research on cook stoves, biofuels, wind turbines, engines. So anything you could kind of think about in regard to clean and renewable energy. So that's really exciting as well. And Adam, I'm happy to connect more offline as well to talk about sustainability in particular, because that is something CSU is very well known for. And as Todd mentioned, the automation piece of it. What will also happen in your curriculum is you're going to take technical electives. So you build your foundation in your first 2 years, and you're taking your general classes. And then in your last 2 years or so, you're taking technical electives. And those will really connect you to your interest areas. So you could take some technical electives that connect you directly to automation. And it depends where you're kind of shifting with automation, like which industry and things like that. But we can definitely customize and build out a degree plan to make sure that you're hitting all of those passions that you have here.
And then kind of going to another question that popped up here, what year will environmental and civil majors essentially split off to this?
I think you went on mute there, Todd.
It looks like, can you hear me?
Yep, you're good now.
Okay, sorry, it said the host muted me, so.
Yeah, that was me, I'm sorry, Todd.
Oh, you're fine. Oh, good, you're here, Shannon. There's a question on what year do they split off between environmental and other civil focuses?
Yeah, so I was going to answer that. Thanks, Todd. So most of the classes, the first 2 years are really pretty similar as far as the foundational classes, like the math and physics and chemistry. We do, however, separate our introduction classes, Civ 102 and Civ 103. They're the same class, essentially, but Section 1 is taught by a civil instructor, and Section 2 is for the environmental majors and is taught by an environmental environmental instructor. So you do split out kind of in the beginning and throughout your entire major. The good thing about civil and environmental is that they do work well together. So while 103, like 102 and 103, you separate into sections and are taught by different instructors based on your major, the labs are all done together. So you do end up working together with, you know, the major, that either civil or environmental. The real difference between civil and environmental in our majors, in our department specifically, is that environmental does a lot more chemistry and does microbiology. There's just a lot more science, science as far as natural science like biology and microbiology, toxicology, those types of classes, where civil would go into materials and structures and transportation. So it really is about your third year when you truly, the curriculum actually separates a little bit more distinctively. Sorry, that was kind of a long answer, but I hope it answered your question.
And there's another question on classes relating to reducing carbon emissions.
So, and we do, we have an amazing faculty member here, Dr. Ellison Carter, and she works a lot with our air quality. So she does a lot with air quality and remediation with regard to that. So yes, we do have, actually in the environmental major, there are 2 required air classes that do deal with carbon emissions and those types of things.
And I do know there's also, and I'm not sure if they've incorporated it into classes at this time, but there are some tools out there that have been looked at for doing life cycle costs, sort of like structures. You can do life cycle costs on, say, making concrete. What kind of carbon emissions and energy does it take to actually mine the materials for that, the emissions it takes to actually build your structure, and then what it actually takes to either recycle or dispose of those materials. I think that maybe in either a later elective that they use some of those tools, but they do also have ways of looking at that for other areas other than just environmental. Are there any other questions? I think there's one question there for Jackie on the chat. Otherwise, Shannon?
Yeah, are you talking about answering the email or the message?
Well, I would say that is
about with the mechanical engineering seminars. So we'll post all of the seminars from the whole entire week on the YouTube channel. So feel free to watch those next week once we get everything posted online. And then if you want to connect with me directly, so I can connect you with the Department of Mechanical Engineering. So if you have any specific questions or concerns or anything like that, we can make sure to get those addressed.
Thanks, Jackie. Yeah, so if there aren't really any more questions, gosh, I'm sorry, I keep fumbling over my words here. We have our next session is at 11, and that is going on with our department head, Dr. Shackelford. And then, as I was mentioning, the 2 separate sections of Civ 102 will have both instructors, the civil instructor, Dr. Siller, and the environmental instructor, Dr. Carlson, all 3 of which can answer many questions with regard to our curriculum as well as future after your degree in civil and environmental engineering. And I think we may have a couple of our student ambassadors there as well. So a really big information session we'll have at 11. And I do see, what discussion do you have in civil engineering and forest fires? I'm not quite sure I understand the question.
My guess is probably building in forested areas and expansion of people into areas where forest fires can affect them more would be my guess of where that question is going. I don't know if we actually have much discussion on kind of, I guess, you're looking at like the human impact of civil engineering and nature around it. That would be my guess, Shannon.
Okay, yeah, and I honestly, that's pretty specific, and I'm not really sure that I have an answer to that. I'm sorry, Adam. I mean, I know that we have, I don't really know. I'm sorry. But that might be a question that we could get answered in the next information session with our department head.
Well, and I was just going to add, kind of coming back to like majors and minors as well. So I know within the Warner College, there are some disciplines that directly relate to like fire management and fire safety. So there might be some classes or, you know, some areas of study that you could undertake as part of a minor as well. And that's the great thing about a minor is it can be outside of the College of Engineering. So you could take something like, you know, in the Warner College of Natural Resources. So again, it's all about really customizing your degree plan to make sure that you're really getting the skills and the knowledge that you need to enter the industry you wish to enter into. So there's definitely opportunity. And I'll shoot you, Adam, I'll send a link here to all of the courses relating to fire management here at Colorado State University.
Thank you so much, Jackie. I appreciate that. You're very good on your feet, and I appreciate that a lot. So yeah, so I guess we can kind of wrap this up if there aren't any more questions. Todd, I appreciate you so much. Your video was fantastic. You did a great presentation, and it was very informative. So thank you.
Thank you. I hope everyone has a great day.
Yeah, everyone, have a great day, and we will be, I think it's, Jackie, you can correct me if I'm wrong, but I think we can get out of this session and then everyone will just come back. Anyone who wants to come back will come back at the 11 o'clock.
Perfect. Yep, that will definitely work. And then I was just going to let you know that Ananya, who's one of our ambassadors, dropped a link to a YouTube video that's on our site, and it's specifically about civil engineering faculty modeling communities for wildfire resilience. So that's something that might be really interesting as well, Adam. Great. Well, we appreciate you all tuning in. Yeah, we'll see you here shortly in the next 10 minutes or so for the general information session. Enjoy the rest of the day.
Thanks, Jackie.
Thanks for now.